Hi, and welcome to TeamMed's Deliverable Number 4 presentation. This labor tracker app is developed with the purpose of aiding an obstetrician or midwife's delivery versus C-section decision for obese pregnant patients who are in labor. Historically, C-section decisions for obese women follow the same decision curves or partographs as normal weight patients who were in labor. This app uses different labor dystocia curves developed for obese women, as published in the American College of Obstetrics and Gynecology's Green Journal in the year 2011. In this presentation, we will start with our final Gantt chart update. After that, we will provide a project status update covering three key areas: core functionality, additional features, and deployment. After this, we will provide a thorough demonstration of our product. Once the demonstration is completed, we will cover future research and our conclusions. We hope you enjoy. In our high-level Gantt chart, activities since the last update are highlighted in light green. We have completed the necessary back-end functionality, refined the front-end implementation, and have successfully completed testing and deployment. Our detailed Gantt chart shows a more granular item-by-item analysis of the tasks completed since the last update, specifically our if there is time requirements of enhancing the multi-patient view, along with elements for testing and deployment. Our project objectives were based on our initial catalog for the project we were assigned, as well as our interaction with our team mentor. For these objectives, we have made the following progress. Objective 1. We were successfully able to generate a customized partograph based upon the provided information from the Green Journal to create a custom partograph to be viewed in our web application. The patient's height and weight are entered, her BMI is calculated, and based on this, the appropriate BMI dystocia curve for patients is selected and plotted, including the decision for those for uniparous or multiparous patients. Additionally, our customized partograph can be easily downloaded as a PDF. Objective 2. Our web application enables cervical dilation data in centimeters to be entered for each customized partograph. Objective 3. Our web application clearly marks the green or safe zones and red or danger zones based upon the patient's progression through her delivery. Our graphing technology makes it clear when a patient's dilation measurement exists in a red zone. Objective 4. Our web application's partograph is specifically designed to enable subsequent cervical measurements to be entered alongside existing measurements. Objective 5. Our web application provides an overview screen of currently active partographs, enabling a provider quick access to multiple labors occurring at the same time. Based on this assessment, we have met all of the core functionality requirements as specified in our original project specification.
In terms of additional functional enhancements, we have developed this solution to be useful in a multi-provider practice as an out-of-the-box with minimal setup. Once the initial administrator account is configured, additional providers, patients, and partographs can be easily added. Additionally, our user interface was developed with a responsive, mobile, and tablet-friendly design using high-quality and visually appealing interface elements. In terms of our deployment status, we have successfully deployed to the provided URL, which requires you to be in the Georgia Tech VPN to access. We found this to be one of the most time-consuming processes in the final weeks of the project, as we ran into extensive issues. And we owe many thanks to the Georgia Tech support staff who assisted with our deployment. Our deployment process, Docker utilizes critical automation to ensure all of the appropriate packages are installed, as well as providing initial sample data fixtures in Django.
We will now begin our project demonstration, focusing on the 5 expected project objectives. To gain access to our application, you need a username and a password. Once you log in, you can select the option you would like to perform. We are going to select Add Practitioner. Practitioners are added so that patients can be assigned to them. Once we create our practitioner, we are going to add a patient. We provide the patient's name, their height in inches, their weight in pounds, which is used to calculate the BMI, as well as their age and information about prior deliveries. We then assign them to a practitioner, in this case the one we just created. We can now select our new patient from our patient list, and from there create a new customized partograph. This partograph is based on the information provided to us from the Green Journal and can be easily downloaded in PDF format to be shared with the patient. For this patient with a BMI of 64, we can see that the curve clearly differs from an additional patient I created, which only has a BMI of 25. This satisfies our first project objective, creating a web application using particular woman's information to generate BMI individualized partographs that can be easily downloaded via PDF. Once the customized partograph has been completed, it becomes possible for a provider to enter specific readings about that patient as pertaining to the partograph. Dilation information, descent information, date, time, and hour, as well as station information are recorded. Error checking is provided to ensure that only appropriate values are entered. Once an appropriate value is entered, it is then graphed against the customized partograph. This completes our second objective, an interface where cervical examination data can be used and plotted against the woman's customized partograph. Once the customized partograph has been created, it is possible for a provider to view the partograph over time and provide subsequent cervical exam information to be entered and plotted against the initial values. Additional values can continue to be provided. The dilation information and the time information entered by the provider is then continuously graphed against the prior values. This satisfies project objective 4, the ability to view the partograph over time by the client with subsequent cervical exam information entered and plotted against previous exam data. So far, all of our exam points have clearly existed in the white or green zone where it is clear that no danger exists. Once we choose to enter a point that occurs outside of this zone or in the red zone, it becomes clearly graphed in the red zone or the red portion of the graph under the curve. Should the trend continue to occur under the red zone, future points, as long as they occur in the red zone, will continue to be graphed there as such. This functionality completes our third project objective, the ability to indicate whether a laboring woman is in the green zone or the red zone based on the most recent cervical examination. Once we step out of an individual patient view, we have the option to view entire patient lists, all of the patients currently entered in the system, as well as the information pertaining to any current or active labors. The current and active labor list shows information such as dilation, descent, and risk based on information in the customized partograph. This completes our fifth project objective, the ability for a client to track several women's labors simultaneously. This concludes our demonstration of the 5 project objectives. Additionally, account information can be updated, and once done, the user can log out of their account.
As we wrap up our official class-based work on this project, we have identified 2 potential future steps if this project continues to move forward. The first step is to gain additional feedback from real-life usage of our product to provide any ideal enhancements. The second would be continue to monitor research in the field of customized partographs and identify additional ways in which we may graph relevant information to assist providers with making decisions. In conclusion, we would like to first off thank our project sponsor, Dr. Carlson. She was always quick to respond and gave us everything we needed to get started and succeed with this project. Secondly, our project mentor, Taylor Blaine, provided invaluable support through the semester, making this project possible. Finally, in our final weeks as we prepared for deployment, Eric Soto assisted greatly with resolving issues with deployment. As a team, we enjoyed working on this project. Thanks from all of us on Team Med.